Good morning, guys. It's Monday. So the plan for today, we're going to try to continue with scientific notation. And I'll walk you through some of the examples as well as what I'm hoping you get through. So if you were looking at the e-board, we are on Monday and Tuesday, scientific notation. Hopefully you completed the 320 bundle and the 319. So this one's going to take a couple of days. If you click on that link, and read it. There's a bunch of stuff there. So I attached some the two worksheets here. You can either print them out, okay, or just view them and write your answers with the number on paper. If you don't have ink, that's fine. And also I attached quizzes and two Edulastics in Classroom. So if you go to your Google Classroom, you will see them there. Let me just go there and view that real quick. I believe I have, yep, there we go. So in Classroom, and give it a second there. All right, so let's just say we go to block 9, 10. 1, 2 should be the same. Okay, here's some practice. Okay, where are we at here? Here's the quizzes, okay, in scientific notation. And I have the Edulastics, adding and subtracting, and then the Edulastics should be multiplying and dividing in there as well, down there. So that's what I'm looking for you guys to get done, again, through today and tomorrow. So I know it's a lot of work. So just looking at our scientific notation, we did notes on this the other day. Let's see here, what did we have? Okay, the two papers that we printed out were these here. I printed them out for you. These are online. So if we're going to try to write a number into scientific notation, we know that if we're going to take a smaller number, so if we move it to the right, we just count how far to move it over to get the decimal point between a whole number, right? One number, then the decimal. So it's going to be negative 2.65 times 10. Now, how would we get back to the original, right? Move 2 places, so that's negative 2. That negative tells us we'd move it that way. So if we start with a real big number, the decimal point is right here, right now. So if I'm going to move it 1, 2, 3, 4, so 5.3 times 10 to the 4th, and I got, okay, now how would I get back to the original? I'd move it 4 to the right, so that means it's positive. All right, and that's what I did for each of these going through. I'll take a picture of this and post it. So if I start with a really small number, like number 6, and I move it 1, 2, 3 spots, so I get 6.71 to get back to the original. So it's going to be 6.71 times 10, not just to the third power, because if I set it to the third, I'd move it this way, to the negative third. Negative means I want to move it to the left. Okay, and that's what I did with each of these. This guy, number 12, don't get confused with it. It's already in basically scientific notation. I wouldn't give you like anything like that now, but negative 4.5 times 10 to, I didn't have to move it all at 0. And if you remember, any number to the 0 power is just 1. Okay? So if you take a look at those, you can view what I did on that. On the second part of this, now we are given a number in scientific notation. I think this one's easier. If it's a positive exponent, we just move it to the right that many places. And if it's a negative exponent, we just move it to the left that many places. So we're not counting zeros necessarily. We're moving it that many decimal places. The nice thing about number 2, if they're negative, I basically going to add, because there's only one number here, I'm going to go 1 and then 6 zeros. So I'm going to add 6 zeros and then that 1 move. So that kind of helps me when I do that. So kind of just showing you how I would do it if I was given something like 8.43 times 10 to the 6. I just do this, 8, 1, 2, 3, 4, 5, and 6. That's my 6. Okay, I just kind of count out as I go along. If I had 7.3 times 10 to the negative 4th power, I just do this. I know it's going to be 1, 2, 3, 4, right? So I'm going to do 1, 2, 3, 4, and then I just write my other numbers. That would get me back into standard form. All right, then we talked about our addition and subtraction. Remember, when you're adding with scientific notation, your base, your exponents have to be the same, so we might have to adjust one of the exponents. So it's your choice. If I want to adjust this guy to make this a 10 to the 6th, 10 to the 5th, so right now I have 1.2 times 10 to the 5th. I'm going to add to that. Now, if I want to move it over one more place here, it becomes 10 to the 5th, right? If I move it one, so this becomes 53.5 times 10 to the 5th. Now I can add these guys together. The rule is I can add the 1.2 and the 53.5, so it's going to get me 54.7. I just added this to this, and then times 10 to the 5th. That would stay the same. Now we got to be careful. Notice this guy, whoops, I lost you guys there, sorry. This right here is not in scientific notation, so it becomes 5.47 times 10 to the 6th. I got to move that one more place this way, which means it creates one more there. All right, pretty tricky stuff. So here I have a 10 to the negative 3rd, 10 to the negative 2nd. So let's take, and I'm going to make this 10 to the negative 2nd power. So let's put 6.91 times 10 to the negative 2nd power plus, now if I'm going to move it 3 units this way, right, if I just move it one more unit this way, now it becomes negative 2nd, so 0.24 times 10 to the negative 2nd, and that's my goal, to get these guys the same so I can just add them. That's using my distributive property. And 6.91 plus 0.24, kind of do that on the side, 6.91 plus 0.24, we line them up. That would get me a 5, 11, 6, 7, all right, 7.15. And the nice thing about this guy, I'm already in scientific notation already. Okay? And that's what you need to do. Same thing with subtraction. All right, what I would probably do is make this guy, it doesn't matter which one you move. If I make this guy 10 to the 2nd, it becomes 3.67 times 10 to the 2nd, and then minus, if I'm going to move it over one place, right, that gets me here, so I got to move it this way, so it becomes 0.16 times 10 to the 2nd. That would get me back to my original. Now I can just go ahead and take 3.67, subtract 0.16, and then whatever I get is going to be times 10 to the 2nd power. And 3.67 minus 0.16, it's going to be 3.51. So that's 3.51 times 10 to the 2nd power. All right. They're the more challenging ones. I think the multiplication, much easier. All we got to do is multiply our numbers together, and then we actually do multiply these guys together. But when you multiply 10 to the 8th times 10 to the 6th, you basically keep 10 and just add 8 plus 6, and you get 14. What's 4.3 times 2? If I double 4.3, that's 8.6. 8.6 times 10 to the 14th, that's in scientific notation. We're good. All right, if I have negative exponent, no big deal, nothing changes. I still multiply 6 times 1.5. If I do that, I believe I get 9. And then since I'm multiplying 10 to the 3rd times 10 to the negative 2nd, I add those guys and just get 10 to the 1st. That's my rule for multiplication. Division, I divide these guys out. 7.8 divided by 1.2. Okay, now you might have to do a little division on the side here. 7.8 divided by 1.2. Move that over 1, move that over 1. So 12 goes into 78. What's that? That's 5, 6 times is 72. Subtract, I get 6. Bring down the 0, and we get 5. So 6.5 is going to be my answer there. So when I do this guy, I get 6.5. The rule when we're dividing is we subtract exponents, always top minus bottom. So 10 to 3 minus 4, it becomes 10 to the negative 1st power. That guy's in scientific notation. And I would stop there. All right, if I was doing something like letter F, I would probably simplify the bottom first using my multiplication rules, then divide out. All right, so check those out. I'll finish this paper, put the answers on, and this other operations is the same thing right here. All right, operations with scientific notation. I'll fill that guy out, and that should get us through pretty much the next couple of days. Again, I'll probably post some other things on the e-board for you to do. Check out the quizzes, do the edge elastics. Don't be all worried about necessarily the grade on that right now. I just want you to practice it. and complete it more than anything else, and then we'll worry about quizzing and getting some grades in at a later date. All right. So the plan today and tomorrow, work on the worksheets that are posted for you there. Complete the quizzes that's in classroom, and then work on the 2 edulastics that's in that are posted in classroom. All right, guys. All right, keep at it, and I'll be back in touch soon.